All right, hi folks, this is Larry Maslino. I'm recording a video for Section 3.2. It has to do with more rules for finding derivatives. Remember, a derivative is a function that gives you the slope of the tangent line to a curve at a specific x value. So in this Section 3.2, we want to talk about what's called the product rule and the quotient rule. Let me show you what these rules are about. So it turns out that when you want to take the derivative of the product or multiplication of two functions, it doesn't just equal the derivatives being multiplied. It's a more complicated scenario than that. So when you have the derivative of one function multiplying another function, here's what you have to do. You write down the first function as is, multiply that by the derivative of the second function, we're calling that g prime of x, and then write down the g of x function as given times the derivative of the first function f prime of x. Okay, so let me write this in a way to make it just a little easier to recognize. So if you're taking the derivative, I'm just going to write it as f times g. Remember, this is not going to just be f prime times g prime. It's more complicated than that. So what I'm going to do is just copy the f function down as is, multiply that by the derivative of the g function, and then I'm just going to copy the g function down and multiply that by the derivative of the f function. All right, so this is called the product rule because it's the rule that you use when two functions are being multiplied. What about two functions being divided? That's called the quotient rule. And think of f as the function on top, g is the function on the bottom. This rule says is take the function on the bottom, multiply it times the derivative of the function on the top, and then subtract the function on the top times the derivative of the function on the bottom. And then you put the denominator g of x squared on the bottom here. Okay, let's go ahead and do some examples. I think the best way to see these rules, to better understand these rules, is to see them worked out in some examples. Okay, so let's talk about the product rule. Again, notice the product rule, when you take the derivative of two functions, it's not f prime times g prime. It's not, it's more complicated than that. All right, let's do some examples here. All right, let's take the derivative of this function, and notice it's one parenthesis multiplying a second. I'm going to call this first parenthesis f, and I'm going to call the second parenthesis g. And now I want to plug into the product rule. All right, so it's telling me to copy down the f function as is. So notice I'm copying the f function down as is. Now I'm going to take the derivative of the g function, that's what this part is. Now I'm going to the back here, it says copy the g function down. So notice I'm just copying the g function here times the derivative of f. All right, well now let me work this out. The derivative of x to the third plus 3 is 3x squared. Of course, the derivative of this 3 is just a 0. Let me come back here. What's the derivative of 2x squared minus 1? Well, that's this 4x. Now I could just do some algebraic simplification. I can multiply these out, combine like terms, and I end up with this result down here at the bottom. Okay, so you just have to be very careful to follow this product rule very closely. I think it's a very good idea to label the first function as f, label the second function as g. That makes it easier to plug in to the product rule template. All right, let's do one or two WebAssign examples. Now, let me mention one item to you that when it's not too tedious to actually do the multiplication first before taking the derivative, you can do that. So let's look at number 1. If we wanted to, what we could do, so what I'm going to do for this first one is before taking the derivative, let me actually just multiply the 10x squared through the parenthesis. So that would give me 10x to the third minus 60x squared. Notice now the function is not a multiplication of two functions anymore. So now I could just take the derivative without using the product rule. So that's really up to you whether you want to simplify the function first to where you don't need to use the product rule. Well, for problem 2, I could do the same thing. I could multiply these two parentheses together and then take the derivative. And I would not need the product rule if I did it that way. But I'm going to use the product rule because I just want to get some practice on setting up the product rule. So let me call this first function f, and I'll call the second function g. So now let me plug into the product rule. Okay, so now I want to know what's the derivative. Well, I'm going to take f. That means I'm just going to copy down 7x plus 8 times the derivative of the second function. The derivative of g is going to be the derivative of 8x minus 9. The derivative of 8x is just 8. And the derivative of that 9 in the back is just 0. Okay, so that's g prime. It turns out it's just 8. Plus, now for g, I'm just going to copy down the g function. That's 8x minus 9. And then f prime means take the derivative of the first function. That's the derivative of 7x plus 8. That's just going to be 7. Of course, I can multiply inside of parentheses here and combine like terms to clean that up. I'll let you do that. But I just want to show you how you might work through the product rule. All right, let's do maybe one more example here on the product rule. And again, sometimes, multiplying these parentheses together would be quite tedious. So it might be more efficient to just use the product rule and not do the multiplying up front if the multiplication would end up being more work. All right, how about if we do the bottom example? Let's go to the bottom example. I'm going to call this first parenthesis f, and I'll call the second parenthesis g. All right, let's take the derivative then. It says first copy down f. So I'm just going to copy that down as is. So that's x to the third minus 2x. Now I need the derivative of the second function g. So I want g prime. When I take g prime, the derivative of 3x squared is 6x. And the derivative of 2x is just 2. Okay. Plus, now I'm going to take the, just copy down the g function. So that's going to be 3x squared plus 2x. And I have to multiply that times the derivative of f. So now I'm going to multiply that by the derivative of f. The derivative of f is the derivative of x to the third minus 2x. That's 3x squared minus 2. And again, you can multiply these out using some algebra, combine like terms to get the final answer. All right, let's look at a couple of examples of using the quotient rule. The quotient rule is a little more complicated. So here's what the quotient rule says. And let's jump to a WebAssign example so we can work this out. All right, let's do the top example here. So again, I think it's a good idea to label f and g so you're clear. So in my example, f is going to be the top, the numerator, and g is going to be the denominator. All right, let's work out the derivative using the quotient rule. Quotient rule says start out with g of x. So g of x is just going to be the bottom, the denominator, which is 10x plus 8. Times the derivative of the top. But the derivative of the top is the derivative of 2. But the derivative of constant is just 0. So the derivative of 2 is 0. Minus f of x, but that's just a 2. times g prime of x. G prime is the derivative of the bottom. The derivative of the bottom is just 10. All over the denominator squared. And that's 10x plus 8 quantity squared. All right, well, on the top, remember this first part is just going to be a 0. So it looks like I'm ending up with the answer negative 20 over this denominator of 10x plus 8 squared. And that's going to be the answer. I can't really do any simplifying. All right, let's go to the next slide, maybe do one or two more examples of using the quotient rule. All right, how about if we do this top example? And again, the first thing I'm always going to do with these kinds of problems is label this top part I'm thinking of as F, and this bottom part I'm thinking of as G. So let me use the quotient rule. First part, it says if I want the derivative function is plug in G. So I'm just going to copy the denominator, 10x squared plus 9x plus 7. Okay, now I need f prime. That's the derivative of the top, but the derivative of x is just 1, and the derivative of that 1 in the back, that's just a constant. So the derivative of a constant is 0. So this is just going to be a 1 minus f of x. So that's x plus 1 times the derivative of the bottom. The derivative of the bottom, that's g prime. That's going to be 20x plus 9. And then divide by that denominator squared. So that's going to be the 10x squared plus 9x plus 7. And of course, that whole quantity on the bottom has to be squared. Numerator, you could multiply the expressions out, combine like terms, and simplify the numerator. All right, let's go to the bottom example. The bottom example is a little different. It's asking you to find the slope and then the equation of the tangent line to the graph of this function at the point they're giving us, which is 2,4/7. All right, well, to find the slope of the tangent line, that's really finding the derivative function, and then evaluate the derivative function when x equals the x value they gave me, which is x equal 2. All right, well, first thing we have to do is find the derivative function. All right, well, the first thing I'm going to do is label. So I'm going to think of the numerator, f as this x squared, and g will be the bottom, x plus 5. All right, so let's find the derivative function. I'm going to use the product rule. All right, first I'm going to start off with g of x. Well, that's the bottom, so that's x plus 5, times the derivative of the top, f prime, but the derivative of x squared is 2x. Subtract. Now I'm just going to copy down f of x, which is x squared, and that's going to be multiplying g prime. That's the derivative of the bottom, but the derivative of the bottom is just 1. And then this is all over the denominator squared, which is x plus 5 squared. Okay. You know, I'm not going to bother to simplify this. Of course, I could. I could simplify the numerator, but I'm really just looking to evaluate this when x equals 2. So let me just go ahead and do that. What I want to do now is just work out what is f prime of 2. Remember, this is going to give me the slope of the tangent line. All right, so let me just plug in 2 in place of x. So that's going to be 2 plus 5 times 2 times 2 minus 2 squared all over 2 plus 5 squared. Okay, let's see, let's work this out. This is going to be 7 times 4 minus 4. So it looks like on top we're going to have 26. And on the bottom, 2 plus 5 is 7. 7 squared is 49. So this is like a messy fraction here. 26 over 49. Okay, that's the slope of the tangent line. So that would be the answer to this first part of this problem. Then, oh, I'm sorry, wait a second. This is 28 minus 4. This would be 24 over 49. My apologies, 24 over 49. All right, now let's go ahead and find the equation of the tangent line. So I'm going to use this formula that says y minus y1 equals m times x minus x1. All right, well, our x1 was 2, and our y1 was this 4/7. So I'm going to plug in y minus y1, that's y minus 4/7, equals m, that's 24 over 49, x minus 2. Okay, now of course you can solve this equation for y. It's going to be y minus 4/7 equals 24 over 20 over 49x minus, and when I multiply this inside, it looks like it's going to be 48 over 49. The last step would be adding 4/7 to both sides of the equation. I'll let you do that to finish up and come up with the equation of the tangent line. Okay, so when you want to find the equation of the tangent line, you first have to find the slope of the tangent line. To do that, you calculate the derivative function and plug in the specific x value being given. When you do that, you get the slope of the tangent line. Then for the equation of the tangent line, you can use this formula from algebra. Y minus y1 equals m times x minus x1. All right, I'm going to just set this one up for you. So here's an example. It says the concentration of a certain drug in a bloodstream after t hours is given by this function. Find the rate at which the concentration is changing. You know, is the concentration of the drug increasing or decreasing in the bloodstream? You'd like to know that. So find the derivative function. Well, notice here you would need to use the quotient rule. So I would call this top part the f function, call the bottom part g, plug into the quotient rule. That's how you'll come up with the c prime of t. Then they want to know how fast is the concentration changing at different times. Really what they're asking you to do is to evaluate c prime of 0.5, that's for half an hour. Then evaluate c prime of 2 for 2 hours and c prime of 8. So once you have the c prime function, you'll just be plugging in these numbers in place of t to work out these numeric values. Okay, I hope this is helpful as you're working in section 3.2.